So I'll do a quick introduction as my presentation is getting ready. I'm Bob Dutcher. I'm Vice President of Analytics and Big Data at Oracle, based in Redwood Shores in California. That covers, from an Oracle perspective, that covers all of our business analytic type products, our data science products, as well as our big data products as well. So I've been in the industry for quite a while, if you can't tell by my age. I think I'm getting a little bit of feedback here. Okay. Better? Okay, perfect. So been in the industry for quite a while. Been doing analytics for quite a long time. Training-wise, my background is I was actually a bachelor's in physics and a master's in astronautical engineering. Fairly familiar with some of the more technical aspects as well as some of the business aspects of the space. But let me see here if I can get the slide turner. So one of the things I wanted to kind of lead off with, and I think Steve kind of hit a few of the areas that I was going to talk about, is really when you look at kind of AI, big data, data science, what is actually possible has really been redefined. Things 10, 15, 20 years ago that were just science fiction are now just commonplace. And more things are becoming more common. And that's created a lot of change in the industry, which I mentioned that Steve talked about. It's impacted many of us in the room. It's impacted me professionally, and it will have more impacts on us going down the line. And one of the things I want to talk a little bit about is how it's impacted Oracle itself and how we are kind of approaching the whole topic of artificial intelligence. But I also want to give a few examples of some of the more innovative folks that we've been working with in the data science space as well, to give you kind of some of the big picture, some of the big impact stuff that AI is actually doing out there as well. And then I'll talk a little bit more about the enterprise kind of within an actual company. So one of the customers that we've been working with is the World Bee Project. So as many of you might know, that the bee population has been declining. The World Bee Project was an initiative to examine the bee populations. They actually put sensors on beehives and around bee areas. So they collected millions and millions and millions of data points as well as audio information to basically do examination of bee habits and also to look at what actually is impacting bee populations. One of the things that they were able to discover is that in many cases they were able to start understanding the conditions in which bees would start swarming, which is a bad thing because when bees swarm, usually the queen either is dead or is dying. So one of the things that they started finding is that with minor changes to crops and how we actually do agriculture, you can actually have a big impact on the bee population. So for instance, I think everybody's probably familiar with crop rotations. We know that you take one crop, you rotate for another crop to keep the soil healthy. What they found is actually bees also like a diverse habitat. So for instance, in the Central Valley in California, where you have the almond farmers, you have almond tree after almond tree after almond tree. That winds up being very bad for the bees because it doesn't create that diversity that they like. So something as simple as putting every once in a while a little break of lavender actually has a positive impact on the bee populations. So this is something that AI can do for the positive for the planet. And if you think about it, it has a huge impact because I think it's somewhere around 70% of the world's food it needs pollinators to do that. Another example is the National Health Service, which is the UK's public health service. What they did is they implemented a data lab. So they took data science and started looking at the way that medical services are actually consumed within the United Kingdom. I mention this because this can show that a relatively small team can have a massive impact within an organization. So in this case, what they were doing is they were looking for various types of fraud, where you have both practice fraud as well as identity theft. But they were also looking for the betterment of the actual healthcare system that they were producing as well. And in that case, what they were looking for is drug combinations, and effectiveness of drugs, so that they could make sure that people were actually getting the drugs that were most effective, and that they were not getting prescribed different types of drugs that could have damaging side effects when combined together. So this is, with a team of a little bit over a dozen data scientists, they started examining the data from the National Health Service. And within months, they were able to identify over $550 billion, or billion pounds, which is actually about 700 million, $700 million of impact. Right now, they're on target to find about a billion pounds per year of annual savings, while still improving the health care of the patients. So a very big impact with a relatively small team. Now, I want to take a little bit of a step back before I talk a little bit about Oracle and kind of our approach and what we're thinking about when it comes to artificial intelligence. A lot of these technologies that we're talking about aren't actually new. So if you look at artificial intelligence, it's been around since before most of us were actually born. It was actually in the 1950s. And if you look at the definition of artificial intelligence, it's basically any kind of programming that you do to a machine to mimic human behavior, okay? About the 1980s came along the machine learning. And that is really where machines can actually start learning. So even machine learning has been around for quite a long period of time. And then in the last, give or take, 10 years, you started seeing deep learning, so neural networks. Now, also from a definitional point of view, the way that we kind of define the world of AI and data science is, data science to us is really, it encompasses all of AI, but it's actually more than AI as well. Because a lot of times the results of a data science project is actually data, is actually information that is then shared for humans to make decisions on. And as a matter of fact, that's usually the most common use case for actual data science within companies. And then as you go down, now this is not to imply that any one of these layers is less or more important than the other. It's actually, it's more of a case of choose the tool that works best for the job. You're not going to use a Ferrari to deliver a pizza. So in many cases, standard kind of rule-based or semi-rule-based programming, it's enough. It actually does the job, it does it effectively, and you don't have to over-engineer it. On the other hand, if you're doing facial recognition, you're probably doing some form of deep learning. And then, of course, there's everything in between. As mentioned in one of the previous sessions, in the financial services space, if you want to do explainability, you have to use, you're not using deep learning as well. You're using some more standard kind of models out there. So you want to use the tools that actually fit the job the best. What has actually changed, though, in the last 60 years is actually the amount of data that's available to us. So that's where that big data, because to me, to be honest with you, big data and data science are almost interchangeable, because I don't think you can have one without the other. Although I would argue that if you're just doing a straight linear regression, it's not a big data problem. You don't really throw more data at it, it doesn't help. But if you're doing more sophisticated analytics in data science, then data is absolutely the most important thing that you can have. The other thing, though, is, and I say the cloud, technically it doesn't have to be the cloud. It's a matter of storage and compute, both GPU and CPU compute, depending on what kind of data science you're doing. But if you look at, the reason I say the cloud is, from my point of view, the cloud is the most efficient way to do data science, to build models and to do AI. And when I say efficient, I'm talking about from a cost-effective point of view. Because I can have tons and tons of servers and racks, but the nature of data science is a little bit spiky. If I'm training models, I might be doing something that's very CPU intensive. I might build a different model that's very GPU intensive. So being able to have that elasticity that I get from the cloud actually allows me to do data science in a very cost-effective kind of manner and to be able to scale up and scale down as I need to. Now, I get asked a lot about, give me this great use case of AI or data science. And it's a really hard one because it's kind of like saying, here's a pile of rocks, show me the perfect rock. There's so many different use cases out there. So I kind of like the first one, which is the credit card transaction. For folks that are of my age, if you traveled a lot, 20 years ago, for instance, one of the things that I always happened to me, I did a lot of international travel, and I was doing lots of credit card transactions. And I found that if I was traveling and hitting 2 or 3 or 4 countries within a week, which is actually not hard to do on a business trip, usually about the second day, my card would stop working. So from the way it impacted my life is I had to carry 3 or 4 different credit cards, knowing that 1 or 2 of them were then to start getting rejected, and then I'd have to pull out the next one to start using. And the reason is the AI that was being used was not very sophisticated. It basically just said, hey, if somebody is actually hitting more than 2 countries, in a day, or more than 1 country in a day, something's probably up. Let's put a hold on the card. So what I found now, though, is when I travel, it never happens. Because they've learned my patterns, which is when I'm traveling a lot. I travel sometimes to less travel destinations, and the credit cards just understand, this is my pattern, this is who I am. So these kinds of things affect our lives in every day, and we've seen the improvements. We get everything from personalized mail. Now, the last one has not yet happened to me, but I'm told by our applications teams that it is something that is kind of the big thing in the HR world, which is from a retention point of view, finding employees that are at risk of retention, have a high value to the company, and then being able to use AI to determine that these folks should get some spot bonus or something to retain them because they might leave. So I'm looking forward to when that happens, but we'll see. The other thing is, on the use case, if I look into a company, the number of departments and businesses that AI actually can have an effect on is also unlimited. So the good news for folks in the audience who are data scientists, aspiring data science in the AI world, there will be no limit to the work that gets done. To some effect, the only thing that stops us from building AI to solve lots of internal corporate type process issues or business issues is really a cost-benefit analysis. Does the building of the model and deploying of the model and the maintaining of the model hit my investment barrier that I want to achieve? And does that actually, is it actually provide that investment or does it go over the bar of that investment that I want to go? So it becomes a simple cost-benefit analysis. And of course, the beauty is, over time, we're already starting to see the access to AI bar lower and lower and lower, as well as the actual building and consumption of AI decreasing as well. So that bar keeps getting lower and lower and lower. So the amount of problems that we'll be able to throw AI at will continue to expand. One of the predictions that Oracle have made several years back is that by 2025, 100% of cloud applications will have artificial intelligence in it. That 50% of enterprise data will be actually managed autonomously using artificial intelligence, and that 85% of all interactions will be automated. Now, since that, as I mentioned, that was about 18 months ago or so, the assumptions that we made when we made this prediction, have all been exceeded. So chances are we'll actually achieve this before 2025, actually. So it's actually accelerating much faster than we had even considered. Now, if you look at the Oracle approach, this is marketing speak. As a company, we are all in on artificial intelligence. We've realized that artificial intelligence is the future of the company. And with that is we've actually taken an AI everywhere strategy within the company. So if I take, for instance, the actual top one, ready to go, again, that's just marketing speak. What we've done is we've looked at how can we actually implement AI into every single one of our cloud-based applications out there, whether it be our finance applications, HR applications, supply chain applications, et cetera. On the build side, this has to be, we want to create a robust environment, including open source. So we've actually been a fairly big contributor now and increasing to open source, which frankly, coming from Oracle, is not something that we historically have done. So I'll give you that. But this is really to make sure that there's a robust environment so that people can actually build and do data science, so build AI and do data science. And then the last is, the way that we kind of look at it is, the applications is usually about process automation. So it's about AI improving the actual process. And the one below, it's actually about AI improving the actual deployment, running, and maintenance of actual applications that you have that you're actually using within your organization. So there again, it's leveraging AI throughout that. So there is probably not one department in Oracle that does not have some AI that they're working on to be implemented within our products as well as within the company itself. So when we look at the application side, a few examples of what we're doing and how we're doing it and the impact is, I'm a manager, so I have people that work for me. I have to approve expense reports all the time, and my organization is somewhat larger, so I get lots of expense reports. I'll tell you a little secret for those of you who aren't managing people. Managers don't look at every expense report and scrutinize every single line item. So at best, we do a quick skim and look for anything that looks like an anomaly and hit approve. And usually we try to do that within 5 minutes for every single expense report we have in our queue. So for me, having the ability to actually have AI in the background that's looking not only for company policy violations, which is your basic kind of stuff, but actually looking for anomalous behavior within the expense reports that are being submitted to me actually makes my life a lot easier, and I have a lot more confidence when I'm hitting that approve on that. On the HR side, we've talked about a little bit of retention type analytics. So using AI not only to find candidates, but AI to actually retain people. Supply chain, it's about efficient supply chains, which there's unlimited amounts of AI that can be incorporated into those operations. So if we look at the results, we can actually do a lot of productivity and time saving. This doesn't mean our job goes away. It means that I can be doing more productive things. Because to be honest with you, I don't actually enjoy approving expense reports. So when we look at autonomous, this is about optimizing workloads, so tuning data management systems, running data management systems autonomously. What this allows businesses to do now is, what used to be in the realm of just IT, I can, as a business owner, as a business leader, I can have sophisticated data management capabilities within my group without having to have an army of IT folks to support that. So that gives me a lot of agility and a lot of autonomy. On the development side, the development environment is very complex and robust. We like to say that AI, it's a team sport. It's about development working with data scientists. And I'll focus a little bit more on the data science side. So on the data science side, you also want to make sure that you have flexibility. Again, it's using the right tool for the right job. It's not only about taking your data and bringing it up and running it at a process layer. It's also about sometimes it's more effective and efficient to actually run the analytics or to run the models and do the processing where the data resides. So it's the flexibility of doing the processing where you need the processing to be done. And then it's also then incorporating within business analytics. As I mentioned, business analytics a lot of times is the way that the business views and sees data, and it's being able to take that data science that I do, so that forecasting model, and embed it into my actual, my dashboards and my visualization products, so it's invisible to the executives. They don't even know they're using AI. And then when I mention the team sports side, it's not just data scientists and application developers, it's IT. IT has to manage a plethora of open source tools that the data scientists are using. And it's not just for them, but it's for the data scientists and for their organization, because if I build a model, I want to be able to reproduce that model. I might pass that model off to somebody else, and they need to reproduce that model. And of course, as I mentioned, since it's a cost-benefit analysis, the business has to be involved in many of the steps of the process as well. So I'll just kind of finish out a little bit on another company that we've been working with, Everything But the House. It's an online auction site. And here, the interesting thing is, if you think about their problem is, they auction off tens of thousands of items in a year, okay? And they auction it off. If I'm the CFO and I need to do a forecast, a financial forecast, how do I actually do that based on stuff that I don't know what it's even going to sell for? They actually built and implemented a model which actually can predict the revenue of an item within 36 cents. So if you look at that impact on that business, now they can actually do accurate financial forecasts with that. So when AI and data science works all together and well, this is kind of you can get some pretty amazing impacts within the organization. So I'll just end this now, and I think we're right now for lunch, so I'll end it, and if there's any questions, I'll take them. The one thing is, from the Oracle's perspective and from your perspective, when you're looking at an enterprise AI approach, it's really about making sure that AI is integrated across the business, and making sure that all the applications can incorporate AI, or if you're looking for vendors that leverage AI. It's about viewing data science as a team, making sure that it is a fully collaborative process, which a lot of cases it isn't. And then the last is, it's about also thinking about leveraging AI from an enterprise perspective within the enterprise to actually manage, run, and maintain the systems that you have. Okay? So I'll go ahead and take questions. Thank you.
Have you thought about the implementation of quantum computing in AI being done anytime soon? And if so, what sort of advancements do you project in the world of quantum computing and AI?
Okay. So quantum computing. That's a great question. The Oracle approach, frankly, has been a little bit more on the enterprise side of the house. So it's more about making employees more productive, and it's more about using AI to manage the infrastructure that you have within an organization. And then it's also about providing the tools associated with developing AI. So I would say on the quantum computing, to be honest, I'm not an expert on that area. I would think that would just broaden our capabilities. It's not something that I've actually put a lot of thought into, so I might let somebody else answer that one. But I think it actually provides a lot more capabilities that we can choose from in the future. I apologize, I don't have a great answer for that one. Yes?
Yeah, so speaking of the capabilities, big data, AI applications, how would you just consider yourself in terms of strengths and weaknesses compared to Microsoft, AWS, Google Cloud, for example?
Yeah.
What's the realistic scan of what you think?
Yeah, the space is a bit different. So one is, if we take it from the AWS part, let's just take it from a cloud perspective specifically. What we like to say is, we have the more of the Gen 2 cloud. So one of the advantages that we have of being a little bit later to the cloud, and this is my way of spinning that we were slow to jump on the cloud train. But one of our advantages to actually being slow to jump on the cloud train is we were able to learn from a lot of folks' mistakes. So we've actually hired, our cloud team is actually based in Seattle. I think it's kind of down the block from Amazon. And no surprise, a lot of our folks come from Amazon. One of the things that we've done there is we've really focused on putting AI within the actual cloud infrastructure. So where it comes to like security, having automated bots for security, et cetera, as well as being able to have more software like our database run autonomously, where it can be deployed and managed without much effort at all. That's where I think we have our advantages. The other area where we have our advantages is, and this is probably why we focus a bit more on the enterprise spaces. If you look at Oracle, one is we're a data company, which is great. So that helps us both in the big data space. We've kind of adopted the not only relational but object storage and your traditional Hadoop structures. But what we've also done there is incorporated. Is basically look at our applications that we have. So if you look at like AWS, Google, et cetera, they're not going to have those enterprise applications. So there's a space that we play in. So our cloud, we kind of view it as more of a, so we take the third party plus we have our own. And then we kind of, circle it with kind of AI and security in it. So long answer, we have some stuff that they don't. Obviously, AWS is a market leader, and Azure has a bigger market share than us in the cloud too, but we're hopefully catching up. So that's at least my hope. Yes?
I just had a general question, probably maybe a precursor or question for the discussion panel that takes in privacy, but wanted to just throw out like great example when you say that you're probably in different countries. I'm a data scientist with Verizon. And when you go out of the country, the cell phone knows that you are there in which company.
Yes.
So now, in order to get not annoyed by credit card company declining your transaction, it would be great to exchange data with Verizon to see that, okay, you have problem, and most likely this is like, not the false positive, so don't have to go that. Similarly, if you want to stop the opioid epidemic in America, you can predict who is going to be an opioid addict and have augmented doctor decision of the doctor and AI system together. But there's a data gap, let's say Medicaid, like I just lost a job, let's say, and I'm having Medicaid, and all my data was with Blue Cross Blue Shield. Medicaid just has 3 years of my data. Now, if the state government want to predict that, or anybody else want to predict that, it would be great to like exchange data. So, an example. So if, at Oracle, I think you have several such clients, and you're in a high position, so you are in a position where you can convince clients or to exchange data. So what is your take on where we are? It definitely is a no-brainer. It's for betterment of the society and revenue. So what is the take on, your take or, pros and cons, or what are the hindrances in this exchange of data? Do you think that's...
Yeah, so first off, agree with you. And actually, my understanding is there's actually various projects kind of like that where your phone is tied to your ATM and that sort of thing. So there's a lot of those stuff going on for the anti-fraud side. I know on the medical side, I've worked quite a bit there. To be honest with you, a lot of times from what I saw, and this is me looking from the outside, so I'm not a healthcare expert at all. Actually, rules and regulations were sometimes one of the biggest impediments. Sometimes for good reason too, though. So, yeah. And the reason is for instance, if I'm Anthem Blue Cross, I actually don't know everything. I don't have your medical records. I have, codes and costs. which does not allow me, it allows me to do some data science against it, but it actually doesn't allow me to do more in-depth stuff. There's some serious privacy issues around that too. So I think that some of that has to be dealt with. So I think there's motion going for better data exchange, but to other stuff earlier, there's also the possibility of abuse, because if you start providing way too much information around medical, et cetera, the last thing I want in the world is where an employer can actually use AI to determine that you're then be too expensive to my healthcare plan, so therefore I'm not going to hire you, I'm going to hire you instead. So I think actually those tend to be a lot of the problems. Obviously there's some technology problems because some of these systems are complex, but I have my personal sense is that it's kind of some of the privacy and some of the rules and laws and how things are regulated and governed that actually cause some of the bigger issues. But that's just my point, or my take. So I think I'm holding you guys up for lunch, or you people for lunch, excuse me. If you have questions, feel free, I'm here. So thank you very much.